Hi there. I'm going to try and keep this fast, so hopefully you guys can be ready for our test and our vocab quiz. Picking up where we left off, so this should look familiar to you. We were talking about different map projections. This is the azimuthal or polar projection. Remember, for a lot of these projections, you just want to know what it distorts, what it was useful for, and that's about it. I guess you should be able to identify it. You'll also recall, hopefully, that you had been able to fill in these blanks. You could do it a bunch of different ways, but I'll just give you the easy way. You could either talk about equator or equal area maps. That's the most common map types that you probably see, so you should know the difference. The first blank could be either equal area or Mercator. I suppose you could talk about azimuthal, but that's pretty easy to identify. It's the only round one we are going to look at. But if you chose Mercator for that first blank, you would remember hopefully that you're going to look at Greenland or Africa, and you're going to compare the size. In real life, Greenland is 1/14 the size of Africa. However, for the last two blanks on here, if Greenland is the same size as Africa, or perhaps even bigger, then it's a Mercator map. If you were to fill in these for an equal area map, you could say you can easily identify an equal area map by looking at the size of Greenland in Africa. If Greenland is much, much smaller than Africa, then it's an equal area map, meaning that they are all represented at their true size. So let's get on to new things. First, there's a few other things to learn about maps. One other type of thematic map is a great type called a cartogram. Cartograms are excellent because they're I think fairly intuitive to read. They manipulate the size of objects to reflect how much data they have. So if we were to do this for, I don't know, the first thing that comes to mind is like students in the school. If you were like that much cooler than everybody else, then your size would be bigger. That way you could easily tell who or what had the most of something, in this case coolness. Just by looking at how big they are. So apply the same idea to countries and some other statistic, and you have a cartogram. We'll look at some examples. This is a great example of a cartogram. You can see the definition there is that it's a map where the size and shape of land is distorted to reflect an amount of something. You might be able to guess what this map is showing us. So take a look at the map. We've kind of talked about this year, at least what the topic of the map is. This is manipulating the size of certain countries. So look at the biggest countries, and maybe it will jump out at you that this is a cartogram based on world population. You have the largest country in the world by population is China, and this is the largest country on the map. India, you can see near China, is the second largest country on the map, and it's the second largest in population. The third largest is the United States, and that is obviously third largest in size. Fourth largest is Indonesia, fifth largest Brazil, and then from there I'm gonna guess it's Nigeria. I would have said Bangladesh. Well, I think it is Bangladesh. Who knows, but you get the idea. It's a cool way of portraying the world and data. Alright, I think we talked about that already. Let's go on. There's lots of different ways to show data. We're not going to go over all of them, but two of them that you have vocab words for are density and distribution. You can see my definition of density is simply how common something is in an area, and then distribution means where is it. So let's say that this map of US public libraries really only had one library on it. They wouldn't be very dense because there'd only be one, and it's a great big country. Wouldn't matter whether it's on the East Coast or the West Coast or somewhere in the middle. One library divided by the whole country, or rather one country divided by the whole library, means for not a lot of density of our libraries. Then, if you were to think of the map that you see now, obviously not all our libraries are evenly distributed across the country. Some are more bunched together, so their distribution might be important to note, just because some states that don't have many people, like Wyoming only has 500,000 people roughly, they have very few libraries, and they're pretty far apart. So the distribution here is that they're far apart. You don't see many that are close together, and of course wherever they are close together is probably a city. So if we look at Chicago, We've got tons of libraries down here in St. Louis, and way more around Chicago. So their distribution is that they're jam-packed together. They're also dense because there's lots of them, but they're also pretty close together in many cases. So density is how common things are. Distribution is where things are. I like dot density maps. They're easy to read. A few other things. This used to be a vocab term, but I deleted it because we have a new course description this year that means we teach different things than we used to, but I'm still going to tell you about it because it's easy to remember and might still show up on the AP test. They don't always give us a very clear description of what you need to know and don't need to know. So we'll cover it just to make sure we've got our bases covered. Mental maps are very easy. This is what you think of the world in terms of like how it looks in your head. It doesn't just have to be the world, it could be your world. So you have a very good mental map of your house. You could probably navigate it pretty easily with your eyes closed just by using that mental map in your head. I, on the other hand, have no idea what the inside of your house is like. So I have a terrible mental map of your head. Generally, you should keep in mind, though, that the older you are, the better or bigger your mental map is. You may have traveled a lot. You may have a bigger mental map than me, but I highly doubt it. I've probably been way more places than you, and it sounds like bragging, but it's not. So my view of the world is just more complete than yours. It doesn't just have to be the world. I've been been in many other buildings. My mental map of Loyola Academy is probably better than yours. All the places I've lived. So your mental map is merely just a map in your head, as the definition says. So you could have an example of this, of any of the things that I just told you about. But keep in mind, the older you are, generally, the better your mental map, or the bigger it is. Toponyms, that is a vocab term you should know. This is the name of things. Nym, you may know, means name. So a toponym is a name for a place. That's it. Sometimes they can give you clues about that area's history. So the fun example I'll give you, or at least the relevant example, is Chicago. You could think about where does that word come from? Why are we called Chicago? And another question you might have had about Chicago is, at least the name, is that it's spelled with a CH but pronounced like an SH. So why is that? Not every place name will give you some of these clues, but Chicago certainly offers two. You may know that Chicago's name is a Native American word, that no one's really sure what it meant, but it might have meant something great. It also might have meant smelly wild onion or skunk weed, or it might have meant bad smell, so we probably just have a foul odor. So that explains some of our history. We used to be occupied by Native Americans, of course, but also, what about that spelling? The spelling it with a CH but pronouncing it like an SH, goes back to French times. The first European explorers of this area were French, and since they named us, wrote out that name, Chicago, that Native American word, they spelled it the way that they would spell it, which is to say that they pronounce a CH like an SH, like think of the word champagne. So we are called that because of our Native American background and spelled that way because of our French background. We were actually a part of France for about 150 years. So that addresses the question of why Chicago is pronounced that way and where the word comes from. One other thing to discuss then is scale. This is a vocab term from earlier in the unit. I can't remember the exact number of it, but you might want to look at your scale note card just to make sure that what you have on there matches up with what's up here. Scale kind of has a couple different definitions, so maybe it's worth adding both to your note card. The scale definition I gave you before is that the size of an area that you look at can be described in many ways. In geography, in this class, we're often going to talk about things at the global scale, or things at the national scale, or the regional scale, or the local scale. But scale can also relate to how a map relates to, let me start that sentence over. Scale can also have to do with how things on a map are sized in relation to real life. It's all kind of relative to other maps, but I'll give you some better, more clear overviews here. So you could generally have a small scale map or a large scale map. A small scale map is a map where the things on the map are tiny. So if you think of a globe is a small scale map because the United States might only be 2 inches long, so everything would be shrunk down to such a tiny, tiny size. That would be just about as small of a scale as you could get. And the smaller the globe, the smaller the scale, because you got to make things smaller and smaller and smaller to fit on that globe. A large scale map then is the opposite of that. You're zooming in somewhere, so the things on the map are closer to life size. Of course, they're still probably very small compared to real life size, but they're going to seem way bigger than on a globe. So again, just to contrast these, large scale maps show you things zoomed in so that they're closer to life size. Small scale maps show you things that are super duper 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 tiny. So if I were to show you a map of Loyola Academy drawn on an 8.5 by 11 piece of paper, normal piece of paper, Loyola Academy would be in some ways sort of close to life size. But if I were to look at Loyola Academy on a globe, the scale is so small you wouldn't even see Loyola Academy on there. It would be smaller than a speck of dust. So few questions or examples of this. Which do you think is the smaller scale? Scale can often be portrayed as fractions, so hopefully you know whether 1 over 100 is bigger or smaller than 1 over a million. So let's see here. Which is the smaller scale? Think about the fractions. The smaller the number, the smaller the scale. So which is smaller? Is it 1 to 24,000 map or 1 to a million, the small scale map? In a 1 to 24,000 map, you may not know what that means, but that just means every inch of space or mile of space, whatever, probably an inch of space on a map is equal to 24,000 inches in real life. And then the other scale would be an inch equals a million inches in real life. So which would be the smaller fraction if you change that colon to a slash? Hopefully you know the answer would be the second one, 1 to a million, because you're dividing 1 by a million. That gives you a tiny, tiny amount of space. Whereas a 1 divided by 24,000 is a larger number. It's closer to real life size. Lastly, which would provide more detail? Small scale or large scale map? Think about it for a second. Hopefully you know that if the small scale map has very few details, because everything's so tiny, then that would not provide you a lot of detail. The tininess prevents a lot of well, detail. So a large scale map would be more detailed. We'll go through some examples of maps, and you simply just should try and figure out, hey, what type of map is this? There's more than one type, so I said not type but kinds. So you've got options like reference or thematic, Mercator, equal area, azimuthal, or compromise. We didn't talk about a compromise map, so don't worry about that. I took it off this year. And then we only talked about some of these, really only one of these types of ways of displaying data. I'll still talk about a choropleth map. You'll see lots of choropleth maps in your life. You might even see a lot of graduated symbol maps, perhaps even isolines. You've seen a bunch of these already. I'll still go over them. I don't think you need to know them for the AP test, but I could be wrong. They were on in the past, and then they took them out of our description. So who knows? Hopefully, if we're looking at these, you can at least figure out if this is a reference or thematic map. Remember, a reference map is one you often refer to, and we in class said that the map you'll most often refer to is going to be referred to for directions somewhere. So can you get directions on this map? Probably not. They don't even number these latitude and longitude lines. Hopefully you remember latitude goes sideways, latitude going sideways, and longitude lines go north and south. So nothing is labeled here, no roads, no countries. This looks like a thematic map, and the theme looks to be land cover. So the sort of yellowish areas are dry land, deserts, green areas, of course, forests and things like that. So this is a thematic map. Is it a Mercator, equal area, azimuthal, or compromise? Don't worry about the compromise. This is an equal area map. Hopefully you can look at Greenland and see that you could fit Greenland into Africa many, many times. So this is life size, or I should say a proportion of life size. And finally, how's the data displayed? None of these fit with this one. This is none of these types, so don't worry about that question. But that means that every map generally has at least two kinds of types or kinds. Reference or thematic, and then there's the projection, and then if you can figure it out, how the data is displayed. This is a choropleth map. Choropleth maps change the color. I'll rephrase that. They change the shade of the color to represent more or less of something. So this is a monochromatic choropleth map, meaning it just uses one color. You could have multiple colors and different shades of those, but I'll show you an example of that in a few minutes. This one shows the death rate of children underneath the age of 1. Which is a sad topic. You can see that, as a side note for human geo-knowledge, the places in the world where you see the highest infant mortality rates are in sub-Saharan Africa. That's a good general thing to keep in mind, just that sub-Saharan Africa generally has the lowest incomes in the world, highest death rates. I think these things kind of tend to go hand in hand. So is this a reference or thematic map? Again, you cannot use this for directions anywhere. You would not refer to this to help you out with getting somewhere. So this is a thematic map, and of course the theme is infant mortality rate. Is it a Mercator, equal area, azimuthal? No, none of these. It's a compromise map. This sort of mimics the curved edges of the Earth, but still has problems. The size is wrong, the shape is wrong, the distance is wrong, the direction is wrong. Everything's wrong, which means it's kind of a compromise. Nobody gets it all right. Greenland looks like it's a bit too big in relation to the size of Africa. These longitude lines go at angles depending on how far they are from the North or South Pole, so you can't really use this easily for direction because size is wrong, distance is also wrong, and shape is also a little bit funky because you can see like Canada and the stuff near the top and the bottom seem to be warped a little bit. As I mentioned, this is a choropleth map, so we covered all that. It's a thematic compromise map that is a choropleth map. The darker the red, the higher the rates of infant mortality. The lighter the red, the lower the rates. That's the choropleth aspect. This is what's called a graduated symbol map. As for the projection, you don't need to know this, but this is a conical projection. It's easy to see because the curved border here is normally straight on a Mercator or equal area map or even a compromise map. When it's curved here, as you can see, that means they probably put a cone over the Earth, and that's why lines of latitude are not straight. So this is a conical projection. This is a thematic map. It's not a reference map. The theme here is Facebook users per state, and they chose to display this data with graduated symbols. In other words, kind of like a cartogram, it changes the size of a feature in order to demonstrate how much they have of something. So they have larger dots here for more Facebook users. This is a poor symbol choice for a map, or a poor method of displaying data. Because, well, hard to figure out for a lot of people, but once it's pointed out to you, I think it'll make perfect sense. You can't really learn anything from this map because the largest dots will, unsurprisingly, be in the places that have the most people. So what are you trying to learn from this? I don't know. California has the most people, so it's probably also going to have the most Facebook users. Texas, Illinois, New York, Florida, they all also have lots of people, so they're probably also going to have lots of Facebook users. There's nothing really unique about this map that it tells us about Facebook users. This would be interesting if, say, for example, we found out that Wyoming, that has one of the smallest populations, if not the smallest in the U.S., had a way bigger dot than it should. You know, Wyoming's only got 500,000 people, so it probably doesn't have that many Facebook users. If this was a giant dot, you'd be like, man, why do people in Wyoming love Facebook so much? Oh, wow. Instead, this basically just tells us population. That's it. Here's a fun cartogram of the top 11 vehicle markets in the world as of 2010. So the places that buy the most cars. So they've manipulated the size of these countries to tell us how many cars they buy, roughly. They've also given us the data in the chart here, but this is a cartogram. Makes it a thematic map because we can't use this for directions. This is none of these ways of displaying data. It's a cartogram, as I said. And this is none of these. I guess you could put a cartogram down here. It's a way of displaying data. Projections don't really apply for cartograms because this is a manipulated version of what the world looks like. Very skewed. All right, let's move on. This is, hopefully you can tell, a, well, I don't know if this would be reference or thematic. I guess I'd call this thematic. You can't use this for directions, but it's also got a pretty boring theme. The theme seems to be blank world map, so it doesn't really tell us anything. The projection, this is one I wanted to say. Hopefully you can tell if you compare Greenland to Africa. If Greenland could fit in Africa many, many times, this is an equal area map. The data is displayed in none of these ways. They have not displayed any data at all. What a boring map. Let's move on. This is a Thematic map again, can't use this for directions. The theme here is literacy rates. So again, as we saw before with sub-Saharan Africa, a lot of poor people tend to have higher death rates, but also, of course, that means they probably also have lower education rates. So you can see many countries in Africa have literacy rates that are at or below 70 or 60%. This is a compromise map, hard to tell, but the edges of the Earth are kind of rounded a bit here. Most obvious to me up here is Alaska seems to be tilted inwards at the top, sort of as if it were on a curve. So this is a compromise map, even though they don't have the rounded edges. The data is displayed using none of these methods. This is an unfortunate design for a map. This would have been much better if it were a choropleth map. We're measuring just one thing, literacy rates. So why couldn't they have done it like the map of infant mortality rates, where they only are telling you about one thing, in this case infant mortality rates, and using different gradations of that color to indicate higher or lower amounts of something. So darker red here indicates higher infant mortality rate, lighter red indicates lower. On this map, wouldn't it have been nice if they just used the same shade of blue? Higher, darker shade of blue means higher literacy rate, lower shade of blue means a lower literacy rate. Instead, they chose to give us these different colors, which don't really show us. I mean, intuitively, is brown worse than orange? Maybe to some people, but I don't know if it's really that effective. So they could have made this easier to read. Bad map making. This is a reference map. Hard to use it for directions, but you can see that you might refer to this for country names or borders or capital cities. So maybe not directions, but certainly you'd refer to this for common things like looking up country names or something. This is a Mercator map, the first one we've seen. It's also interesting because it's oriented here around the international date line. But Greenland is up here, and you can see Africa is here, and they appear to be about the same size. So it's a Mercator map. The data is displayed in no particular special way. I'll show you an isoline map in a minute. Let me skip through some of these. You can look at these if you want. They're kind of fun, but let's move on. I guess, hold on, let me see if I can find some good maps that I have not talked about yet. Here's an isoline map. This is, again, not a vocab term. It's an old one that I deleted. But you can see lines on here. You've probably seen a bunch of isoline maps because they use lines to show you equal gradations of something. ISO means equal, line means line. So each of these areas in the orange is 5 degrees. Each of these areas between these lines is 5 degrees, 5 degrees, 5 degrees, 5 degrees. So equal line, every line represents a change in 5 degrees. You of course see this a lot for the weather. Or for topographic maps, showing you different changes in elevation as land goes up and down. I think that's it. Sorry this was longer than I intended. I hope this was understandable. Let me know if you have questions. Bye, Felicia.